I'm going to talk about some upcoming developments and a little bit about the architecture. So just as a reminder, or people who weren't very used today, just to tell you what Alchemist is. So basically, some studies have shown that Spark is significantly slower than MPI in certain situations, especially numerical linear algebra, if you have a lot of communication. In that case, you can have overheads that are 4 to 40 times more expensive than the actual computing time. So we want to, and also these overheads and time scales. So the larger your data set is, the more expensive the overheads are relative to your actual computation time. So we want to bypass that. What we want to do is we want to combine the best of two worlds. We want to combine the advantages of Spark with the efficiency of MPI. So the way we do that is by sending the distributed data from Spark to MPI, and then performing the computations, and then returning the results to Spark, so you can do further data analysis on them. Okay, so the new design of Alchemist, everything is now a server-based architecture. Before it was kind of a mix of server and client. It was kind of a mess. Now, what we want to do is we want to have Spark running on a certain subset of nodes, on a cluster or on the cloud, and an application can log onto Alchemist to perform its computations. So you upload its data set, perform the computations, and then the results get returned. So just as an illustration, so we've got Alchemist here, acting as a server. An application logs onto Alchemist. Alchemist dynamically links to MPI-based libraries, so it doesn't have a minute. Alchemist doesn't contain the libraries itself. It just links to them. So whatever data you send from the application to Alchemist, Alchemist then calls the library to perform its operations on the data. And you can have multiple applications logging onto Spark at the same time if you want. So for instance, if we look at the inner workings of Alchemist, let's say you've got 10 nodes. If one of them is a driver, you've got 9 workers. Let's say you've got an application. So ICSI is the Alchemist client interface. So let's say you've got a Spark application that has a driver and 3 workers. So your distributed data set is located on those 3 workers, but you want to perform the computations on these 4 MPI nodes here. So you transmit the data. So that we've got 2 sockets here, or 2 kinds of communication over sockets here. One is between the drivers, that's for metadata and scalar parameters and that kind of stuff. And the workers communicate to exchange the distributed data sets. So then you can perform the computations on these 4 MPI-based workers, and then return the results once you're done. And let's say you've got a second application. It only has 1 worker, but it wants to use 3 workers to perform the MPI computation. So you transmit the data, and then return the results. So what's really exciting for me personally is that we can now move on to other frameworks aside from Spark. So of course, having us with Spark is great, but what if you could use Jupyter Notebook to log on to some existing MPI library? That would be great. That would assist in scientific data analysis, all that kind of stuff. So, so I'm working on interfaces with Python. That would be great if that works soon. And we can support the sparse matrices now. Right now, we're using on the API side Elemental. We're moving on to Scalapack as well to give us more flexibility in the kind of MPI-based libraries we can use. And we're going to use containers as well to enable this to run in the cloud. Okay, thanks.